Hello again. So we just did the first example and you guys tried that second one that we went over. And now we're looking at this guy right here. So if we need to solve this, we again think I want to isolate this variable. I want to get this x by itself. So how do we get the x by itself? Well, we always think, what is the inverse operation? What is the opposite of what's being done? Well, what's the opposite of subtracting 5 or taking away 5? Well, we think about it and we say, well, the opposite of subtracting 5 would be adding 5, right? So then we say, okay, I'm going to add 5. And you'll have to excuse me here. I'm going to try to draw a little bit with my mouse. So we're going to add 5 to both sides. So adding 5 to both sides, we know that a negative 5 and a positive 5 put together, those are, that's a zero pair. So these cancel out, okay? Negative 5 and positive 5, when added together, makes 0. So now we have x, a 0, positive or negative, doesn't matter, it's just 0, equals 23 plus 5 is 28. So now we have x plus 0 equals 28. Adding 0 does nothing, and so then we get our answer of x equals 28. Right, that's going to be our answer there. All right, and you can check that out. You can pause the video now and try this next problem right here. All right, once you have finished this, check it out and see if you got the same thing as what I'm about to do. We need to get x by itself. We think, okay, we got to get it by itself. We need to do the inverse operation, the opposite of what's being done. Well, it's adding negative 11 right now, right? There's a negative 11, or taking away 11 from x, right? Taking away 11 from x. That's how we should think of it. Well, how do we do the opposite of taking away 11? Well, we're going to add 11. If I want to do the opposite of take away 11, I'm going to add 11. And whatever I do to one side of my equation, and again, if the equal sign is the separator here, whatever I do to one side of my equation, I have to do to the other. So this side, everything on this side of the equal sign, I have to do the same thing to this side as I do to this side. So add 11, add 11. This cancels out to be 0, and we could draw that here if we need to. 0 plus x is equal to 47. Now, if you don't want to write x plus 0 over there and you just want to skip that step, feel free to, and we know that it is going to end up being x is equal to 47 as our answer. Is that what you got? Hopefully so. All right, we're going to look at 2 more examples here real quick, and 2 more that you'll try. So what is the opposite? What's the inverse operation to get x by itself? We want this thing by itself. So the opposite of this negative 2 here, what's going on here? If there's no adding symbol and there's no subtracting symbol, then it has to be multiplying, right? And dividing would have a slash, right? So it's multiplying. It's got negative 2 times x. Sometimes you would see it like this, negative 2 parentheses x, right? So negative 2 times x. So what's the opposite of multiplying by negative 2? Well, dividing by negative 2. It's the opposite of multiplying by negative 2 is dividing by negative 2. If I do that to this left side, I then need to do it to this right side as well. Divide both sides by negative 2. That's my dividing lines. Negative 2 on both sides. Negative 2 over negative 2. If we remember from years past, we know that if we have a fraction, like so let's say we have 3 over 3, 2 over 2, 1 over 1, anything over itself is just equal to 1 whole, right? So if we have negative 2 over negative 2, that's just going to become 1 whole. So now we have 1 times x is equal to, and then I think of it like this. What's 14 divided by 2? Or 14 cut in half? Oh, that's 7, right? And then a positive divided by a negative. Okay, I've got 2 terms, and only one of them is negative, right? An odd number, odd number of negative terms, right? Odd number of negative terms, right? So odd number of negative terms, we've got one term, so that means our answer is going to be a negative. Okay, if it was an even number, if they were both negative, that would become it would stay a positive, right? Or become a positive. All right, so now we have 1 times x, which is just x, and so our answer is -7. The missing value that we didn't know has to be -7 for this to be true. Okay, we have to always make it a true statement. We can't lie in math. Okay, so now pause the video, and I want you guys to try this one on your own. All right, did you try it? Hopefully you tried it, and let's see what you got. We have 6x equals 78. We want to get x by itself, right? Isolate the variable. What is the opposite of multiplying by 6? If you said divide by 6, you are correct. Divide both sides by 6. When we say 6 divided by 6, again, that's going to be 1 whole, right? So now we have just 1 times x. And again, if you're fine with skipping this step, feel free. But if you're not comfortable with that, then go ahead and write down the step. Or check your step here if you got it correct. And then 78 divided by 6. So we say 78 divided by 6. We know that 6 times 11 would be 66. Okay, so it's going to be more than that. And if you're checking yourself, as I am right now, because I don't want to give you wrong information, 78 divided by 6 should give us 13, right? So we say 13 is going to be right here. And now we've got 1 times x equals 13. And just 1 times anything is just going to be itself. So now we have x is equal to 13. And don't forget, we can always check these by taking this 13 value and plugging it in right there at the beginning. 13 times 6, oh yeah, that's 78. So we know we got it correct. All right, and the final example here, we have x divided by 3 equals 5. Okay, if we want to solve, I'm going to switch my color up here for fun. If we want to solve, we need to do the opposite, the inverse operation. Opposite of dividing by 3 is going to be multiplying by 3. And can I just do that? Nope. If I just multiply by 3 on this side, it's not equal anymore. I've changed the value of this side. So whatever I do to one side, I have to do to the other. Times 3 and times 3. If these are opposites, just like when we did subtracting 3 and adding 3, or let's scroll up here. If I added 5 and subtracted 5, those cancel out because it's the opposite, it's the inverse. Same thing here. If I divide something into 3 groups, and then I multiply it by 3, I'm canceling these out. I'm undoing it. Why do we do that? So that we get x by itself. So now we have x is equal to 5 times 3 is 15. And there we have it. X is equal to 15. And let's see if it's true. We could always plug it back in. 15 divided by 3 is 5. Okay, we got it correct. All right, pause the video now and try the last one. All right, and let's see if you got yours correct. So we have x divided by 4 equals -9. What's the opposite of dividing by 4? Okay, and I'm actually going to redraw mine here because I like to draw on it. X divided by 4 is equal to -9. I'm going to multiply by 4 because that's the opposite. That's the inverse operation. Multiply both sides by 4. Those are inverse operations, so they're going to cancel out. And so we have x is equal to, once again, 9 times 4 is 36. But we have a negative term and a positive term. let's see, 2 terms, 1 term, 2nd term. This one's negative, this one's not. So that's an odd number of negative terms, right? Okay, so odd number of negative terms means this is going to be a negative term. So our answer is x is equal to negative 36. And you can check your answer by plugging it back in. Negative 36 divided by 4, you could always use a calculator if you need to. 36 divided by 4 is 9, and a negative divided by positive is a negative. Okay, so we got that correct. All right, now it is your turn. Once again, if you think you got the hang of it, I want you to go ahead and head to IXL and try a couple practice problems. So the first thing I want you to try is this first guy here. And the rainbow pen's not working, so I use black. So if we have this guy here, there we go. It wasn't drawing for some reason. All right, this guy is S1. It should have a link on the slide, and this one is S5, okay? I'd like for you to try with S1. You should be able to do that one rather quickly. Try to get it to a 90 SMART score, okay? Try to do that one for practice, and then you can go straight into S5, okay? This one for sure will go into as part of your grade. You can do, I would recommend doing this one first because it's easier and quick, and then try this next one. Once you've done that to 90, then the last thing you'll do today is go to the quizzes that I'll post to Google Classroom and try to see if you can solve one-step equations and if you're doing okay with that. All right. Don't forget, you can message me or email me. You can also join in the Zoom here in just a sec. All right. Thanks, guys. Have a great day.